Now we will understand how to find the limit of x to the power n minus a to the power n over x minus a as x approaches a equals n times a to the power n minus 1. Here x minus a in the denominator is linear, see here, which means the power of x here is 1. Both x and a in the numerator, both x and a in the numerator are raised to the same power n, where n is greater than 1, and its limit is n times a to the power n minus 1. Now how to remember this? The limit is n, which is the constant and same power in the numerator, times a, which is the constant here, raised to the power 1 less than the power n. Evaluate limit x cubed minus 64 over x minus 4. We will solve this limit by two methods. First by factorization method and secondly by the formula method. So the limit is by factorization method as limit x cubed minus 4 cubed over x minus 4 as x approaches 4. Here I have written 64 as 4 cubed. Now here if we put x equals 4 in the denominator, it will become 0 and the function becomes undefined. So we cannot solve this limit by direct substitution. For that we have to factorize the numerator. Now the numerator is difference of two cubes, which is an identity and goes like this: a cube minus b cube equals a minus b into a squared plus ab plus b squared. Now how to remember this? So a is the cube root of a cube, b is the cube root of b cube. So the first factor is difference between a and b. The second factor has three terms. The first term is square of the first cube root, which is a square. The third term is square of the second cube root, which is b square. The middle term is product of these two cube roots, which is ab, and its sign will be opposite to minus, that is plus. So with the help of this identity, we will write the limit as x minus 4 into x square plus 4x plus 4 square over x minus 4. Here x and 4 are the cube roots of x cubed and 4 cubed. So the first factor is x minus 4. The second factor contains three terms. The first term is square of the first cube root, which is x square. The third term is square of the second cube root, which is 4, so 4 square. And the middle term is the product of these two cube roots, which is 4x, and its sign will be opposite to minus, that is plus, over x minus 4. Here, as x approaches 4, x minus 4 is not equal to 0. Therefore, we can cancel x minus 4 from numerator and denominator, and the limit reduces to limit x squared plus 4x plus 16 as x approaches 4. Since this is a simple polynomial which is defined at x equals 4, we can use substitution method to solve this limit. So in place of x everywhere, we will put x equals 4. So the limit becomes 4 squared plus 4 into 4 plus 16, which is 16 plus 16 plus 16, which is 48. Now we will solve the same limit by formula method, which goes like this: x to the power n minus a to the power n over x minus a as x approaches a equals n times a to the power n minus 1. Let us evaluate limit x cubed minus 64 over x minus 4 as x approaches 4. We can write the limit as limit x cubed minus 4 cubed over x minus 4 as x approaches 4. We have written 4 cubed in place of 64 here because this limit goes into this form. Now we can apply the formula and write the limit as 3 times 4 to the power 3 minus 1, where 3 is n, 4 is a, and 3 minus 1 is n minus 1. So it becomes 3 into 4 squared, which is 3 into 16, which will be 48, and which is the same answer as before. Now we will solve this limit by formula method, where the power in the numerator and denominator is a fraction. We have the formula as limit x to the power n minus a to the power n over x minus a as x approaches a equals n times a to the power n minus 1. Here we observe that in the numerator of the function there is no x minus a term. In the denominator of the function there is no x minus a term. So we will divide both numerator and denominator by x minus a and write two separate limits in the numerator and denominator. So the limit becomes, in the numerator, limit x to the power 5 by 7 minus a to the power 5 by 7 over x minus a as x approaches a, and in the denominator, limit x to the power 2 by 7 minus a to the power 2 by 7 over x minus a as x approaches a. Now these functions have been converted into the formula form, so we can directly use the formula now and write the limit as, in the numerator it will become 5 by 7 times e to the power 5 by 7 minus 1, in the denominator 2 by 7 times e to the power 2 by 7 minus 1, which becomes 5 by 7 multiplied by 7 by 2. This 2 by 7 becomes 7 by 2 multiplied by, in the numerator, a to the power 5 minus 7 over 7 divided by a to the power 2 minus 7 over 7. Here 7 will get cancelled and the value becomes 5 by 2 a to the power minus 2 upon 7 over a to the power minus 5 upon 7. Now we can apply the law of indices. A to the power m divided by a to the power n is equal to a to the power m minus n. So according to this rule, we can write 5 by 2 a to the power minus 2 upon 7 minus of minus 5 upon 7, which next becomes 5 by 2 a to the power minus 2 over 7 plus 5 over 7, which will later becomes 5 by 2 times a to the power 3 upon 7, and this is the answer. Solve limit 2x square plus 9x minus 5 over x plus 5 as x approaches minus 5. If you put x equals minus 5 here, the denominator becomes 0 and this function becomes undefined at x equals 5. Therefore, we have to factorize the numerator. Now, for those who do not know how to factorize this numerator, here is how we do it. First, we find the product of the coefficient of x square and the constant of minus 5, which is 2 multiplied by minus 5 will be minus 10, and we will find two factors of minus 10 such that the sum of the factors will be 9. So here minus 10 is 10 multiplied by minus 1, and 10 minus 1 will be 9. So we will split this 9x as 10x minus x and write the polynomial by splitting the middle term as 2x square plus 10x minus x minus 5. Now from the first two terms we will take 2x common, and from the last two terms we will take minus 1 common, and we will get the factors as x plus 5 multiplied by 2x minus 1. We will use these factors in the next limit. So our limit becomes limit x plus 5 multiplied by 2x minus 1 over x plus 5 as x approaches minus 5. Now as x approaches minus 5, x is not equal to minus 5, which means x plus 5 is not equal to 0. Therefore, the factor x plus 5 gets cancelled from numerator and denominator. So our limit reduces to limit of 2x minus 1 as x approaches minus 5. This limit we can solve by direct substitution by putting x equals minus 5. So it becomes 2 multiplied by minus 5 minus 1, which will be minus 10 minus 1, which will be minus 11. Now we will find limit of a rational function where there is a polynomial in the numerator as well as in the denominator. Here x approaches 5. If you put x equals 5 in the denominator, it will become 0. You can check it for yourself. Therefore, this function is not defined at x equals 5. Therefore, we have to factorize both numerator and denominator so that we might get a factor x minus 5 in the numerator and denominator, which we can cancel and further solve the limit by direct substitution. For that, we first have to factorize numerator and denominator. First, factorize the polynomial in the numerator. Here the coefficient of x square is 1. So 1 multiplied by 20 will be 20. We have to find two factors of 20 so that their sum will be minus 9. So we have 20 equals minus 5 into minus 4, and the sum of minus 5 minus 4 is minus 9. When the coefficient of x square is 1, with the help of these two factors, we can directly write the factors of this polynomial as x minus 5 multiplied by x minus 4. Now, let us factorize the denominator. In the denominator also, the coefficient of x square is 1. So 1 multiplied by the constant term 5 will be 5, and we will find two factors of 5 such that their sum will be minus 6. Such factors are minus 5 and minus 1, whose sum is minus 6. Like we have said, whenever the coefficient of x square is 1, with the help of these two factors, we can directly write the factors as x minus 5 multiplied by x minus 1 By using these two factors, we will write the limit as limit x minus 5 multiplied by x minus 4 divided by x minus 5 multiplied by x minus 5. Here, as x approaches 5, x is not equal to 5, which means x minus 5 is not 0. Therefore, we can cancel factor x minus 5 from numerator and denominator, and we are left with limit x minus 5 over x minus 1. This limit we can solve by direct substitution. So in place of x, we will put x equals 5, and the limit becomes 5 minus 4 divided by 5 minus 1, which will be 1 over 4. These are the basics of finding limits of algebraic functions. In the next video, we will understand how to find limits of trigonometric, exponential, and logarithmic functions, and the limits at infinity. If you liked my video, please click like and share and subscribe my channel. Thanks for watching.